Good morning and welcome to another of the Nautical Institute's technical webinars. Today's webinar will be on hatch cover inspections. I'm David Petrayko from the Nautical Institute's headquarters in London, and it's a beautiful day here in London. And I'm joined by Walter Vavlusen from his air-conditioned office in Antwerp. Good morning, Walter.
Good morning, David. Good morning, everyone.
Right, thanks for joining us, Walter. But before we get into the webinar, let me just give you a little bit of background. I hope everybody is fairly familiar with the Nautical Institute, but if not, we are an international professional body, and our main role is to help our members develop themselves professionally, and that's educational material. So we do publishing, we have this very nice magazine, Seaways, that all the members get. We do books, like this one on hatch cover inspection, and events. So this is how we work. We do have a seat at the IMO, and we work with many other organizations to try to share information. Today, we're going to share information on hatch cover inspections. This is extremely important, not just for the good of the cargo, but also the lives of the seafarers. So Walter has been working in this field for a long time. But before we start that, just a few housekeeping notes. This is an interactive session. Probably in the upper right-hand side of your screen, you'll have a control panel with a little white arrow in an orange field that expands or contracts your control panel. Once it's expanded, you have a number of options, but there's an area here for typing in questions. You cannot use your microphone or camera, but you can type in questions. So please keep them short and succinct. Makes my job a lot easier when I see them come in. There are also a couple handouts that you can download up here. If for any reason the software goes into the background, you can find a little icon like this. Click on that and the webinar software will come back forefront. We will have a couple polls. So when we run the polls, all you have to do is tick your choice and submit. If you don't click submit, it will not submit. After the webinar, we have a little closing survey, and I'd ask you to fill that out if you do. It helps us improve our operations. Within a few hours after the webinar, so just be a little bit patient, you will get an email saying thank you for attending. Within that email is a link to a certificate. You're welcome to it. It will be customized with your name on it. Probably by tomorrow, a recording of this webinar will be up on our YouTube channel. So go to YouTube, search for the Nautical Institute, and you'll find this webinar and many others. You are not alone. As of about an hour ago, there were over 700 people registered. So please bear that in mind when asking questions to keep them nice and succinct. Right, we have scheduled this webinar to be 1 hour. It will not be. I've had a look at the slides. The slides are fantastic. There's going to be a great webinar, but it probably will run just slightly over an hour, and we will pick up as many questions as we can. But I will try to not go much more than 20 minutes past the hour, but it will be more than an hour. So Walter started at sea, came ashore, became an inspector in 1988, and has been inspecting ever since. That's a lot of hatch covers he's looked at. He's been at the forefront of developing ultrasonic testing technology. He's written our hatch cover book. Ta-da! And at the end, I will give you a very nice offer on discount for that book. And he is currently the vice president of the Nautical Institute. So, Walter, I'm just about to hand the call over to you, and you should have it now.
Yeah, okay. That should be it.
Yep, over to you, Walter.
Okay, thank you so much for the introduction, David. Thank you, ladies and gentlemen, also for joining me on this webinar. For me, it's an honor, it's a pleasure and a privilege actually to get the opportunity to talk to you about hatch covers on behalf of the Nautical Institute, as well as of the IMCS Training Academy and SDT. And okay, I mean, you can see here from the agenda that we have quite a lot of issues to tackle. And I have tried to structure it in such a way that it becomes and that it remains a practical presentation, something with a number of key items that you can take home after this webinar and that you can use in your day-to-day life and in your day-to-day activities. So we will be talking about some legislation, about the load lines, design issues, inspection issues, and I will end my presentation with what I would call common mistakes, things that we see regularly when we are carrying out inspections on hatch covers. So basically, you will see some slides coming on the screen, and you will see that they are all showing different types of cargos that have suffered wetting damage. And basically, I mean that wetting damage is the result of hatch cover related issues, can be design, can be maintenance, repair, operation, and so on. And apart from that, we can also see that hatch covers are not only generating wet cargo, they are also causing accidents, injuries, pollution issues. And there we can see that most of those accidents and problems that occur are actually related to bad practice and to training issues. In the end, and I think that is the most important thing, whatever it is, whether it's cargo claim or an accident, an injury, pollution, I mean, we talk about claims, and claims is not efficient. They cause delays, they cause loss of output, trigger port state control attention, they cause or they legal costs are involved, customers may be unsatisfied, and insurance issues arise. So definitely having claims is not the way forward. And what do we see? That since 1965, hatch covers have generated claims. I mean, and that is not so unusual. But what we see is that actually that wetting damage claim level has remained steady for about 20 or 30% of claims that are of wetting damage claims in general. So that is quite a huge amount of or a huge percentage. And what I'm then asking myself is that we say, well, since 1965 and up to now, we have done great things. We have been flying to the moon. We invented internet. And in the end, what do we see? That hatch cover problems, they remain, and we made or we have not made that, perhaps the progress that we wanted to do. So you can ask yourself whether hatch covers is the same as rocket science, but it is not. It is basically nothing more than some basics, some logic, and maintenance. And I have about 45 to 50 minutes of time to take you on my hatch cover journey. So I would say let's get started. Let's get it right and tight. So I'm now going back to David because there is a first poll that should be launched now. David, can you take over for a minute?
Yep, okay. The first question is, can we say that hatch covers are weather tight after they successfully pass an ultrasonic tightness test? So the answers are starting to come in on that, Walter.
Okay. So this is something where we actually consider that when we make an ultrasonic test and the operator who is using the ultrasonic testing gear is not hearing anything, then basically we can say that the ultrasonic test has been successfully passed. The question here actually asks whether we can conclude that after we made that ultrasonic test, if the hatch covers are weather tight.
Okay, let's close that out and share it. There you go, Walter. Mixed answers.
After this poll, we get an idea. We can see that about 50% of the audience may say yes, and another 50% say no. During our presentation, we will explain, and you will find out what the right answer will be. We then come to a point which is quite important. People always associate hatch cover claims with damage to cargo or perhaps an injury, but it is important to know that hatch covers are not only cargo related, it is also an important safety issue. It is regulated by different statutory instruments, it is regulated by a number of code of practices and so on, as you can see from the screen here. And perhaps if we go back, we can see that the last one that I put here is the International Convention on Load Lines. And that is a very important and interesting convention, because actually it requires us to go back to the basics of tightness of hatch covers. And what do we see? That Load Line Convention actually says, well, we are looking to the safety of people. We do recognize the need for safeguarding life and property at sea. And in order to ensure that ships and the crew are safe, the load line says, well, the load line will never be submerged at any time when the ship puts to sea, during the voyage or on arrival. And everything actually refers back to, let's say, not to the load line and to how much cargo we can load, but to the freeboard. It is the portion that is actually out of the water and that creates or that gives us reserve buoyancy. That is the extra safety that we have. And from a load line point of view, they will say, well, the hatch covers, they are a big opening. And if you get water inside, because they are leaking, you are actually on a fully loaded vessel that is loaded till the load line. I mean, if you get water in, you are going to add weight to the ship. And if you add weight to the ship, 1 cubic meter weighs 1 ton. So if you get water into the holds, you are adding weight. And at that moment, that extra weight is going to cause the load line to be exceeded. Consequently, your freeboard will be reduced, and in the worst case, it may result in sinking of the vessel. Obviously, we are non-compliant with the International Convention of Load Lines, so the main issue that we have here is that we have to keep water out to protect the safety of the people and the ship and the cargo. Now, compliance with the load line convention requires hatch covers to be weathertight, and that weather tightness is again something where people say, well, what is it? What does that mean? Weathertight? It's such a strange and a funny word. So basically, weather tightness means that in any sea condition, when you are at sea, water will not penetrate into the ship. Now, to make it a little bit more clear, I have added between brackets that water that should not penetrate into the ship should come from the weather side. And the weather side is where we have the weather. That can be rain, that can be snow, that can be sprays, can be green seas, ice, whatever. But any water that comes from outside should not get into the ship, because it's going to add weight and then we get a problem. So some people confuse weather tightness with water tightness, and it's not the same. Water tightness is actually or means that water is not going to pass through the sealing arrangements from both directions across a certain seal and under a certain head of pressure. Like you can see on a ro-ro vessel, if we have a collision, water should not go from the area or the opening in the hull down to the lower areas, or when we run aground, water from the lower compartment should not get up to the higher levels and passing through internal ramp covers and so on. So it's important to comply with the load line criteria, and as we now know, hatch covers have to be weathertight in any sea condition, and hatch cover requirements that are put forward by the load line convention are that the hatch covers should be strong, we should be able to secure them so they remain in place, and they should be tight. And in order to ensure that they are tight and okay, we have to make or carry out tests. And that brings us actually to a very important issue, and that's the design of hatch covers. Designing hatch covers is tremendously complex. It's difficult. We have to take into consideration a lot of different factors in order to get a hatch cover set that is suitable for a specific ship type. You can see from from the presentation here a number of things that are important to consider, and of course there are many more, but these are, let's say, it gives you a good overview of the things that are required to consider. And of course, I mean, because so many different ships have different needs, different trading patterns, different ways of operation, and so on, we end up with quite a big variety of different types of hatch covers for different types of ships. As you can see, I have just shown 8 different types, and there are a few more. But again, I mean, these are the ones that are the most frequently seen nowadays. And the hatch covers that we see nowadays, they are actually the result of a continuous improvement process that started back in the early previous century, where the prototypes of the hatch covers, the steel hatch covers with gaskets, were being pioneered. And ever since, we have made progress, which actually results in quite a lot of different types of hatch covers. Now, another thing is that we can design hatch covers, but we also will have to take into account that there are a number of challenges. And the biggest challenge, perhaps, that we have is that we have to recognize that a ship is flexible. And I always tend to compare it with a box of cookies. If you have a box of cookies and the lid is on the box, it's very difficult to twist or to bend that box. From the moment you take off the cover lid, what will you see? You can actually bend and twist that box with your 2 fingers. Very easy. And that's exactly what we do when we are building a ship. We are having a box and we want to load something into the ship. So we need to cut openings in the deck, and that allows us to load something into the holes. And in the end, we want whatever we loaded in the holes to be and to remain dry, and we have to cover it up. And that is what we do with hatch covers. But knowing that the ship is flexible, our hatch covers have to be strong and rigid for various reasons. We have to open and to close them. And if they would not be strong and rigid, that would not be possible, because they would continuously be moving during operations. We want to load cargo on top of the hatch covers, and the hatch covers have to take the weather load from seas and waves breaking apart on the hatch covers. So the hatch covers are strong and rigid, the ship is flexible, and that results in relative movement between the hatch covers and the coaming. So this is something that will cause a problem later on in the design process. On top of the fact that we know that we have relative movements and distortions, we do know that when we are in port, the ship is in a static condition, but that is only for a short period, and then the ship will set out at sea again, and there she will be subject to dynamic conditions. And whatever you can have in port, I mean, be sure if you have any problems, they will become more significant once the ship is in a dynamic condition at sea. And what we will see, I mean, in port, you can see some pictures of hogging and sagging. You will see some examples of how the panels are actually moving, I mean, horizontally, vertically, fore and aft direction. And we are going to split up those movements in the 3 traditional directions: the longitudinal, the transversal, and the vertical movements, being Fx, Fy, and Fz. And on board of a ship in operation or at sea, we usually get a combination of those 3 directions. So in the design stage, we are going to calculate and simulate the relative movements as far as we do have operational data. Once we don't have data anymore, we can't build in specific features to prevent certain things from happening, and that is the moment where we actually talk about act of God of perils of the sea. It will become more clear later on during this presentation. The basic design challenge that we have here is that whatever is happening outside at sea, and I'm just taking the example of a hurricane, where we can have winds of 180 kilometers an hour, but also winds of 300 kilometers per hour. I mean, definitely the sea conditions will be different, and the mission will be to keep the water out. However, keeping the water out, we need to have specific features that will allow us to keep the water out, and we want to make calculations, but at a certain moment the data will stop. We don't know after we have reached a certain stage of extremely heavy weather or freak waves. I mean, these may be things where we do not have accurate data of. What we do know is that if the hatch covers are properly designed, approved, installed, maintained and operated, hatch covers will not leak in what we can consider to be normal heavy weather. Let's say, just as a little bit a rule of thumb, the normal force 8 and 9 and 10. I mean, that is heavy weather, of course, but it is not exceptional. And we can now come to a sort of a conclusion whereby we can say that if the hatch covers should leak during the voyage, if the cargo becomes wet and so on, and if due diligence can be proven by the ship, which means that the hatch covers are well maintained and taken care of, then there is only one reason why water was able to enter into the ship's hold, and that is as a result of extraordinary conditions, what we call the perils of the sea, and that is the point where insurance, cargo insurance or P&I, will come into the game. So we have the challenges. The main issue is compliance with the load line criteria and to keep water out. From the hatch covers point of view, we know that they have relative movements. We know that's going to cause distortion, and it will be the task of the designing people to be able to compensate for those movements and to ensure that we get and maintain a tight seal. In many cases, people will say, well, okay, that's easy. I mean, we have a rubber packing and that is going to do the job. But I can tell you now already that meeting with the load line criteria, weathertight criteria, is not possible with packing rubbers alone. To understand that, I think we have to look to water ingress as a risk. And basically, if we have a risk, we try to do a risk assessment. We try to reduce the risk and to bring it down to an acceptable level. And that cannot be done with packing rubbers alone. We are actually going to install safety barriers. And the approach with safety barriers is going to allow us to ensure that in the normal heavy weather conditions, water is not going to enter into the ship's hold. And even on top of that, if we should have situations which are really bad, I mean, even then, we are going to try to prevent ingress of water in the hold. The three barriers, and the first one may seem a little bit funny, but it is actually the steel plating that is keeping out most of the water that comes over the hatches. Then we have a second barrier, which is the packing rubber compression bar interface. And what is happening when we are at sea? Water will come onto the hatch covers. It will infiltrate into the interpanel void space, which is above the interface of the packing rubber and the compression bar. The compression bar and the packing rubber, they form a tight seal, but only to a certain extent. As we do not have data of all the heavy weather that can act on the ship, we must be happy with a very good safety margin, but there may be those occasional situations where the distortions are more than what the rubber packing can accommodate, and then we will see that there is a situation whereby the water can infiltrate through the rubber packing, and to comply with the load line and not get into the hold, it will fall and be accumulated by a inboard drain channel. So actually water that comes over the hatches will first accumulate in the interpanel void space, from where it will be drained quickly out, but there is always a certain moment that there will be some hydrostatic pressure acting on the packing rubber and the compression bar, and if the distortions are too bad at that moment, it may be that it infiltrates through that interface, and then it will fall into the inboard drain channel. And then from there, it will be evacuated out on deck. So if we want to know if our hatch covers are compliant with the requirements from load line, I mean, to know if they are strong, if they are secured, we will have to carry out a visual inspection. If we want to know if they are tight and if we want to comply with the requirements of test, then nowadays the most appropriate way of testing hatch covers will be with ultrasound. And that brings us to the next point, and that is the inspections of the hatch covers. When we make an inspection, the purpose is actually that we want to know when the ship is in port, the port being a place where we can still carry out some repairs, whether the weather tightness can and will be maintained when the ship is at sea. So actually, it asks us to predict if the hatch covers will be okay. And how are we going to make that such an inspection? That will consist of, as we just said, the visual part, where we are going to inspect the various components and parts that are responsible for keeping water out, and we are going to make some tests. In the end, when the inspection is finished, we will have to make a report, and in that report, we should pay attention of refraining using weasel words as satisfactory in operational condition, normal working condition, and so on. That is not something that gives you good information on the actual condition of a specific part. What we need are facts and figures. To measure is to know, and that is valid for all domains that I would say, and also for hatch covers. So if we have to measure, if we want to know the exact condition of a piece or part, we have to realize that hatch covers are fine pieces of engineering, and they are working against extreme small clearances and tolerances. We are talking about millimeters. And during our inspection, it will be our task to measure. And if we want to measure something and to know whether it is within or out of the spec, we do need a reference. That reference we can only find in the manual and in the drawings. So that is something that should be consulted at the outset of an inspection, and every inspector should have a small tool set with him, which may consist of a depth gauge and a fillet gauge. Now, what do we see when we are facing hatch cover claims or when we are facing wetting damage claims of cargo? We see that over the years, people have been trained to say, well, okay, if you have wetting damage to the cargo, look to the packing rubber. In most cases, the packing rubber will be damaged. And if people find out that the packing rubber is damaged, the corrective action consists of renewing the packing rubber. And then we consider the problem as solved. And that is actually, or that has been, the industry approach for many, many years. Perhaps it may explain a little bit why we have had this very modest progress when it comes to hatch cover claims over the years. And what I can say is that by just replacing the packing rubber, the problem of leaking hatch covers is not solved. What I tend to say is that hatch covers are actually talking to you. They try to make a message clear. If we make that visual inspection and we see that our rubber packing is damaged, we have to consider that as a symptom and not the cause. The inspection will actually require us to find what is the cause that the packing rubber became damaged, because a packing rubber just by itself will not become easily damaged, as you will understand. So what we have to do is to understand how hatch covers work, to know the function of the key parts, to know inspection criteria, to try to recognize the symptoms, identifying the cause, and then see what is the most appropriate repair. And what I'm going to do now is to pass on a few basic tips and tricks for hatch cover key parts that you can use, whether you are shipboard crew, superintendent, surveyor, repairers. I mean, it's just a few simple things which may actually allow you to make progress and to understand the hatch cover operation and how hatch covers work in a better way. And of course, we have to define what are key parts on a hatch cover system. And you can see we have the packing rubbers, the bearing pads, locators, stoppers, operation mechanisms, draining systems, hatch panels, compression bars, and securing mechanisms. And the first one that I will deal with is the packing rubber. Even though people think that a packing rubber is just a piece of black rubber, I mean, it is not. It's a fine piece of engineering. It has been tested, research has been done, And basically only when they are manufactured with great care and knowledge, then we will get a good packing rubber. In many cases, a good packing rubber is not cheap, and a cheap packing rubber is in many cases not good. But the main issue that we have to identify with packing rubbers is the design compression. The packing rubber is there, as we know, to compensate for those distortions and relative movements, and it must have a certain degree of compression. So how do we get that compression? When we press down the packing rubber onto the compression bar, we get compression. And compression is more than contact alone. It actually means that we are going to compress to result or to cause an imprint in the packing rubber up to a specific depth of the packing rubber's width, nominal width of the or thickness of the packing rubber. Excuse me. So when we are going to compress our packing rubber, we are going to need compression force, and that is actually the force that is required by our packing rubber to compensate and to react to those distortions. You can compare it a little bit with an elastic band. If you stretch it and you release it, it will come back very quickly to its original length. But if we now would be continuously overstretching that rubber band, I mean, at a certain moment, it will lose its elasticity. It will take more time to come back, and it will most probably be plastically deformed. It will be a little bit longer than it was before. The same logic we can use for hatch cover packing rubbers, where we can say, well, if our packing rubber has been overcompressed and is showing some permanent deformation, the reaction time that will be necessary to respond immediately to a deformation or to a distortion between the panel and the coaming is going to be delayed, and that will be a small moment that there will actually be no contact. So keeping your packing rubbers at the required design compression, and to take care that that deterioration process of developing a permanent deformation or set is kept as long as possible. I mean, we have to maintain our packing rubbers at the required compression level. And as you know, we have different types of packing rubbers, and they are all, we have straight pieces, we have molded pieces, we have box seals, we have cat seals, and so on. So that is important to understand. Now, at a certain moment, we will see that by testing the hatch covers, we may get a good impression of the compression that is remaining on the packing rubber if we carry out an ultrasonic test. Just for your guidance, you can see on the drawing here that we have a 90 by 50 packing rubber. And as a rule of thumb, you can say that the design compression is roughly 25% of the nominal thickness of the packing rubber. So if we have a packing rubber of 50 millimeter, the nominal thickness will be 25%, 12.5 or 13 millimeter, as you can see here on the drawing. What you can also see on the drawing is that this packing rubber has a mean compression force of 9,000 Newton or 900 kilo per running meter at 13 millimeter compression. Just imagine that if you have 60 meter of packing rubber, I mean, you have a compression force that is equaling about 50 or 54 tons. What are the frequently seen defects that we see when we make inspection of packing rubbers? Well, we see off-center imprints, imprints which are clearly more than what is allowed. And then we get, of course, that question, okay, but what is allowed as a permanent deformation? And I have made a small sketch here to make that clear. The example here is a 70 by 40 packing rubber, 40 millimeters thick. 25% of the thickness is 10 millimeter, and we consider it as normal, good practice that 50% of the design compression is the maximum amount of permanent set that you can have. So when the packing rubber would develop permanent imprint deformation more than 5 millimeter, it's time to consider changing. Okay. Obviously, we are also going to look for damages like cuts, cracks, wear. Improper repairs, like we can see here, short insert repairs is not good practice. And also replacement with inappropriate types of rubber. I mean, the rubber packing is more than the size alone. We have just talked about that. We have the compression force, we have specific compression ranges. So these are things that have to be considered. So that brings us to a second poll, David, and perhaps you can take over from here.
Okay. So the second poll, is it good practice to put Vaseline on packing rubbers? Choose your answer and click submit. All right, the answers are coming in, Walter.
Okay, good. I mean, putting Vaseline is something that is very deeply embedded in the skills of seafarers. And that is actually what we see a lot during inspections, is that the packing rubber is actually covered with either a thin or sometimes a very thick layer of Vaseline. And what we want to know now is, okay, do you consider this to be good, or do you consider this to be wrong practice?
Okay, Walter, let me just share the answers with you. You can see three quarters say no, 1/4 say yes.
Okay, good. Again, useful to know. Thank you very much, David. I will continue now.
Yes, please.
Okay, so after having talked about the packing rubber, we now come to a second part, which is tremendously important in hatch cover design and also in operation and maintenance. These are the bearing pads. We call them the FZ stoppers, and the FZ stoppers are actually allowing us to prevent steel to steel, or to prevent that the packing rubber would become overcompressed. They are going to keep our packing rubber at the required design compression. And you will see from the slide here that in the old days, the panels were touching the coaming with the side plating of the panel. That resulted in grooving, in damages to the coaming and so on. And through evolution, we have seen that we have designed now genuine type of bearing pads, where the load is taken up by a resting pad on the coaming that comes in contact with the stool on the panel. And we will see that now the panel is not coming in contact anymore with the coaming, which is good. And this is one of the first things that we will check during an inspection, is to see whether that clearance, as we see it here, is still in line with what is mentioned in the manual. That is what we want to measure, of course. And you will see that if everything is okay, that packing rubber is compressed to its required design compression. So on top of that, those bearing pads, they will transfer loads that act on the panel in the structure. They keep our packing rubber at the required design compression, and they will allow some slight movement of the panels. Okay, so they should have a sliding surface that should allow to slide, or to allow the panel to move whenever it is necessary. We also use different types of steel for making those bearing pads, so that actually the wear down is not affecting the free movement of the panels. And bringing or achieving that steel to steel contact is not done by tightening the quick acting cleats, it is done by the weight of the panel alone. We know that if the panel rests on the packing rubber, we will need some compression force to bring it down to the design compression. Well, that compression force is usually provided by the weight of the panel. You can see here some general. Yes?
Sorry to interrupt, but people were unclear whether they should use Vaseline or not. Can you clarify?
Yes, I can. We would come back on it later on, but I can tell it now that using Vaseline is actually not recommended, for the simple reason that Vaseline is petroleum jelly. And if you are going to use Vaseline on the surface of a packing rubber, it will quickly deteriorate the surface of the packing rubber, and it will become actually a little bit more sticky and chewy, and it will definitely not enhance any sliding of the seal, which is also something that is actually not really happening, and it will definitely not preserve the rubber packing over time. The best thing to do is actually to know that normal box type packing rubbers do not need or do not require any lubricant. But if it is necessary according to the manual, then don't use Vaseline, but use the manufacturer's recommended grease, which will in many cases be a silicone-based grease.
Thank you.
Okay, so when we inspect bearing pads, we will see if we do not get too much wear down. We can measure the clearances. We see here rust and wastage on the bearing pads, and we can also, with our filler gauge, check the distance between the bearing pad surfaces. So I think that makes it clear that there are a few key items that are very important to be checked. Which brings us now from the bearing pads to the locators. And the locators do exactly what they say. They locate the panel in the right position. And if the panel is located in the right position, we will automatically get the desired and the required design compression in the cross joints, on the corner pieces, and so on. And that is a very important thing to know, that many leakages of hatch covers can be attributed to the fact that the panel is just not properly positioned and that we fail to achieve the required design compression in a specific area. So frequently seen defects are, of course, excessive clearances. We are talking about millimeters here. Those clearances can be because of improper design, but also wear damage or let's say in-service wear or accidental wear and so on. And we can have also damages and cracks which are affecting the structure of the locators. Another important thing that you have to understand is that we cannot let panels move like they wish. We have to control those movements. Those relative movements have to be controlled, and that is done with the stoppers. And again, we allow for a little bit of clearance so that the panels would not be taking up all the forces that are acting on the hull girder, but we are actually going to limit to a couple of millimeters, again, the freedom of the panels to move. And again, we will see that problems will arise when we leave the panels too much place to move, and because that can interact then with other component parts like the wheels, the cylinders, the hinges, and so on. So that needs to be controlled. And you will see that at this moment, we are talking about packing rubbers with design compression of a couple of millimeters, with bearing pads, which are also important and where the skirt clearance has to be exactly or more or less exactly to what is mentioned in the manual, which is again a couple of millimeters. And we talk about our locators and stoppers where also we talk about millimeters. So it makes it clear that those, let's say, that hatch covers operate against very small tolerances. And it's up to the inspector to define if everything is still within range. So we have the operation mechanisms, which can be cylinders, hinges, wheels, and so on. And what is important is that when you operate a hatch cover system, the operation should be smooth. And on top, we should be able to open up the hatch covers within a specific time window. Again, that is mentioned in the manual. And you can consult that and you can make the check easy yourself from the moment that you are on deck and finding out things. So listen for strange noises, check that all components are structurally sound and that there is no evidence of leakage. Then we come to a drain system, and it's important to know that actually we have a double draining system where we see here the interpanel void space where water will be collected, and if water would infiltrate through the rubber, it comes into the drain channel and from there it will be drained out again on deck. So preventing that water is accumulating in the hold and adding weight. And of course, when water would be collecting in the drain channel, it goes from a cross joint drain channel into the combing drain channel out on deck through the drain pipe and the drain valve. What do we see on drain systems? Blocked openings, repairs with a fire hose, which can be working for as a temporary repair, but not as a final repair, and drain channels which are damaged, which are corroded, and which are just not able to contain the water that is running through the channel. As we said, your panels, they are also very important parts to keep water out, and any structural damages to the panels will allow or may allow or enhance the possibility of getting water inside. So when we inspect panels, we should check for structural condition, the structural damages, cracks and holes and so on, corrosion, repairs, and in many cases we see double repairs, which again may be okay as a temporary repair when it is approved by class, but it is definitely not a proper way of repairing hatch panel plating. We can see high differences between panels, which is an indication that things are not right and that there is something something needs to be checked with regards to the positioning of the panels, and the usual deformations, wavy panel plating, or perhaps overloading of the panel plating and stiffness by cargo that is loaded on top of the hatch covers. Then we know that our packing rubber is interacting with the compression bar, and that compression bar is basically something which is frequently neglected in the maintenance process, and the things to watch out for are what I call the 3 S's. They should be straight, they should be smooth, and they should be strong. And strong, remember that line pressure that we get from the packing rubber when it is compressed to its design compression can be 500, 600, 700 kilos per running meter, so your compression bar needs to be quite strong. And we have 2 types. We can have raised compression bars, like the one that you see here, a little bit what I would say the traditional one, but it is restricting panel movement to a certain extent. But its colleague, which is the flat steel mating surface, like you see it over here, that has no restrictions and gives the panels a little bit more freedom to move and to slide when the ship is in operation. In the old days, we could see that compression bars were made out of mild steel, requiring maintenance, chipping and painting and subject to corrosion. Nowadays, stainless steel is generally what is used. Defects are advanced corrosion to the panel, to the compression bars, which results in uneven compression, and therefore it can be detected in certain cases with ultrasound, or just the plain deformations as a result from contact with cargo, with stevedores, handling gear, and so on. Always remember that deformations, even if it is a couple of millimeters, are going to cause lack of compression. And that compression is not so much. We have 13 millimeters. So if you have an indent of 10 millimeters, you have already lost 10 millimeters of compression or compensating capacity. And finally, we have our securing system, which is a little bit the lashing system of our hatch cover panels. So if we talk about lashing and securing of panels to the ship, that must be, our lashings must be strong, and they must be, let's say, properly positioned so that we get efficiency from the cleats and the cross wedges. So what do we see? The cleats, they keep the panels in place, and at the same time, they allow for a little bit of a slight movement. Remember that we have relative movements. Our panels are, if we can call it, a little bit flexibly mounted with the packing rubber, and also our cleats will have some rubber washers, which will allow the panels to move a little bit, but not too much. And that is actually going to allow us to compensate for those distortions, those relative movements, and maintaining a tight seal. We have manual, automatic, or automatic types of cleats. We have holding down devices, which you can see here, and which are mainly used on container vessels. And basically, we have securing mechanisms for the perimeter around the coaming, but also on the cross joints. It is important that if our bearing pad starts to wear down slowly during its service life, that you can control the adjustment of your cleats by adjusting them with a screw or with a nut, depending on the system. Okay, so what do we check? What are frequently seen problems with cleats and with securing mechanisms? Excessive washers on the cleats. Still that idea that is deeply embedded, that the more difficult it is to drive cross wedges home or to close cleats, the better seal, the better compression we will have. That is not true, simply because we get the best compression when the panel is resting on the bearing pads, which is caused by its own weight, and definitely not by pulling down a quick acting cleat, right? So keep that in mind. Over tightening of cleats should not be done. And because our cleats are actually elements that require strength, think about the fact that over the in-service life of the ship, the cleats will be sandblasted, they will be maintained and so on. And they may actually, through sandblasting and chipping and so on, they may actually lose a little bit of their strength. So do not only look if the cleat is there, also consider whether it is still fit for duty and sufficiently strong. And finally, if we are talking about the load line, we should inspect and check not only the hatch covers, but any opening that will allow water to enter the ship, that should actually be checked and inspected. And you have a wide variety of windows, gas sampling ports, loading ports, access hatches, ventilators. So a lot of things that, that need to be checked. And what is important here also to know is that those openings are usually closed by a gasket, but not by a compression seal. For the simple reason that hatch covers need a compression seal because they are big openings, but those small, and because they are subject to distortion, but small openings, they are not moving relative to the coaming or to the ship as much as hatch covers. So we can generally use normal gaskets instead of compression seals. Again, with other openings, same type of problems. How does the sealing surface look like? Are they corroded, rolled? What are the opening systems? Here you can see severely corroded hinges, which is a injury damage as well. And we come now to some statistics where we may say, well, okay, we as IMCS, we are carrying out a lot of inspections within the scope of the ArcelorMittal vetting program, which we developed 10 years ago. We have a database with 2,000 ships, and just for this webinar, I looked up a number of frequently seen defects, and just since end of last year and now, 313 inspections were carried out. In total, 2,500 defects were found, and we can see that we have a lot of packing related, bearing related, cleat related, and test related defects. Now, these 4 items are the key items according to load line: the strength, the tightness, and the securing. So you can still see that on a random selection of more than 300 vessels, we can still see that a lot of problems are occurring, which makes that there is still room for improvement. If we are going to look to the severity of those defects, we can say, and you will see that a small portion of the vessels, 8%, have no problems with hatch covers whatsoever. Some 26% do have minor problems, which can be dealt with by the crew and maintenance and so on, but the rest are more serious defects, which are difficult to repair, which require the input of service teams or repair gangs. From an ultrasonic testing point of view, 30% of the vessels are passing an ultrasonic test, whereas the rest have either a few leakages or quite a big portion, something like 45%, will have more serious leakages and problems. Okay, so that gives you an idea that a good visual inspection is revealing a number of things where improvement is required. We now come to a point where we are going to test hatch covers, and we have different testing methods, as you can see over here. But by now, and over the last 20 years, after we have been pioneering ultrasonic testing, this has become the preferred method for checking hatch cover tightness. How does ultrasonic testing work? It's basically quite simple. We use piezoelectrical crystals, which, when we press them, will discharge an electrical current. And when we charge them with an electrical current, we are going to get vibration, disturbance of air molecules around that crystal. We put our crystals into a transmitter and into a receiver, and when we charge the crystal in the transmitter, it's going to vibrate and it's going to cause an ultrasound environment, And in the receiver, we will have that piezoelectrical crystal, which will be looking to receive ultrasonic waves and to detect them. So what is going to happen? We switch on our transmitter. We are powering up our crystal in the transmitter. We get ultrasonic waves, and they will be filling up the holes with a certain sound pressure. So those waves, they want to go out, and from the moment that we have a hole, a crack, an imperfection in the sealing system whatsoever, that will come out, and then the surveyor or the operator will be at the outside of the hatch cover with his detection tool, and from the moment ultrasounds are getting out of the hatch cover, he will pick them up, and sound is a pressure signal, so it will compress the piezoelectrical crystal in the sensor, and if that happens, the sensor or the piezoelectrical crystal will discharge an electrical current, and as such, we will be able to measure a leak, to visualize it on the screen, to measure the importance, to qualify and to evaluate the importance of it, and we are actually able to see what is there, but what we cannot hear because ultrasounds are beyond the hearing capacity of the human ear. So we know it's there, and thanks to ultrasonic equipment, we can detect it with pinpoint accuracy. The tests are by now also accepted by class, and what is important here is to understand that a hose test gives you information about contact between the packing rubber and the compression bar, but ultrasound gives you an idea about compression status, which is the reaction force, and that is going to allow us actually to predict that if we make a test in port, if we still have sufficient compression on the packing seal, so that we know that when the ship is at sea, we will get good compression and therefore tightness. We know by tests and so on that lack of contact will give you a readout of about 50% of an open hatch value, and the fail-pass criteria for ultrasonic testing has been set to 10%. And basically, what is happening between the 50 and the 10% is a certain loss of compression. And when we know that we have 10% or less of an open hatch reading, we actually know that we have a good compression on the packing seal, and we can actually say that our packing rubber is still fit for duty and will do what it is expected to do once the ship is at sea. And that is why ultrasonic tests, because we can measure it and we can see it on the screen and we can set our fail-pass criteria, why they are offering additional safety compared to a hose test. So that is what I actually explained just now. And it brings us to the fact that apart from knowing more about the compression of a packing rubber, we also can see other advantages, like one-man operation, no pollution risks, no limitations by temperatures, pinpoint accuracy, easy, repeatable. So holes can be loaded or empty depending on the conditions. So you get much more possibilities to carry out a reliable and a proper test. What is important though is to understand that hatch covers, or that when you are making an ultrasonic test, you have to understand the technique. You must understand also how the equipment works. That is easy to do because we can train people for that, and we do. You must have knowledge on the hatch covers, their maintenance, the repairs, the way they are operated, and then actually you can make a test and you can get what we would say reliable figures and data. But what is the real challenge of ultrasonic testing is to understand the meaning of those figures. And I will just give a small example where we see that there is a lot of confusion actually. If we get a high reading in a small spot in a corner area of a packing system or anything like that, we often speak from a spot leak, but because we get a high reading, it is often referred to as a serious leak, a high reading. Whereas we can have readings just above the 10% of the open hatch value over 4 or 5 meters in a cross joint system, and that is considered to be a minor leak just because it is just above the 10%. Oh, it's not that bad. But actually, I mean, the leak that you get over a long length indicates that you have lost compression on the packing rubber. And if you have lost compression on the packing rubber over several meters, when the ship will be at sea in a dynamic condition, that seal is going to open up in not real heavy weather, but also already in less heavy weather. And if it opens up over 4 or 5 meters and you get some water over, you get massive amounts of water inside. So that is just to illustrate that the value of the leak is not really telling you always how bad it is and how much water you will get into the hull. And therefore, I would say that it is not a value, but the impact on weather tightness that is the most important. And let us go very quickly over a small workshop here. I think that if we see a hatch test report with so many red on the sketch, we know that there are a lot of leaks. And if we would say, well, is this hatch cover weathertight? I think it's easy to say no, there are too many leaks. However, we get a sketch here where there are no leaks. And then the question is also, is this hatch cover weathertight? And actually, we have to say, well, we don't know. We don't know if that hatch cover is weathertight because we may not have heard anything during the ultrasonic test, but load line also requires us to make that visual inspection. And that is something that is not reflected by this sketch. It is possible that you will not hear anything during a test, but that you can find out problems like compression bars which are too thin, or that you can find misalignment issues and bearing pad wear and that type of things, and that would actually render a system not weathertight. And yeah, I mean, it's the both things that actually you need in your evaluation. And then you come to a mixed scenario where you have a few small leaks. And again, here, the question would be, can we load cargo on board of that vessel, yes or no? Well, I would say, technically speaking, it would not be too much of a problem because those spot leaks, first of all, will most probably be easy to repair. But secondly, they may not really allow so much water to get inside. And if water gets inside, normally, in most cases, it will be accumulated in the drain channels and we can deal with it. So you're not going to have what I would say the claim of the century on the cargo. On the other hand, what do we see? That from a due diligence point of view, the duty of the ship owner to maintain the hatch covers in good condition, leaks are not acceptable. So there you have a little bit two different approaches on whether it is safe to load or whether the ship owner can prove due diligence in case of a claim. So basically, as I explained, there are a number of things that you will not find with ultrasonic testing. Ultrasonic testing is satisfying the testing and the tightness part under load line, and the other part is just by the visual inspection. So that should be a clear mission to any surveyor inspector, is that if you want an answer on whether the hatch covers are weathertight, yes or no, you have to make a test and you must make a visual inspection. Obviously, when you make a test, you have to make a report. And nowadays, it's good to know that we have been working together with SDT on the development of a smartphone application for making reporting online, but also on a web application that allows you to produce professional reports in a very quick and a decent manner. So the links are here. You can download it for free from the website of SDT. And finally, if we are talking about ultrasound, and if the equipment would be on board or in the office of a shipping company, why would it not be used for embarking on a condition monitoring voyage? With ultrasounds, finding anything that has to do with turbulent flow, with impact or friction, you get a lot of possibilities to check not only hatch covers, but also condition of bearing, gearboxes, valves, winches, and so on. So it's really worthwhile to consider if it is not good just to take your hatch cover testing program one step further. Which brings us to the due diligence that I already talked about a few minutes ago. And I have made a small list here that is most probably very useful for people when you are involved in a situation that a claim occurs. You will have to submit documents, you will have to prove that you have done whatever is possible to maintain the hatch covers, and then the list that we have here is going to help you with doing that. Okay, so you can see it's a wide variety of things that are going to prove that from a ship side, everything has been done to maintain, operate the hatch covers in a proper way, and trying to avoid, let's say, the inevitable heavy weather or whatever, and water ingress, of course. And that brings us more or less towards the end of my presentation, where I have listed common mistakes. What do we see when we make inspections on a frequent basis is insufficient knowledge about hatch covers. People are not sufficiently trained in how they work, in how to operate them in a safe way, and how to maintain them, or where the limitations for repairs by the shipboard crew are. So overestimating the capability of the ship's crews, overlooking to involve class and or advising flag state when you are making more significant repairs other than maintenance, temporary repairs improperly made, no manuals and drawings on board, no instructions for maintenance, not including hatch covers in the planned maintenance systems, hatch covers not being included in the safety management system. I mean, they can definitely present a danger in case of water ingress. They do cause pollution if the hydraulic systems leak, and they can also cause damage to third-party property. So basically, some instructions should be included in your safety management system. Vaseline on packing rubbers is what we see a lot, and I explained already it is not really good practice. Or people greasing bearing pads to allow smooth movement, but fine dust and grease will act as a grinding paste and may actually accelerate your deterioration process. From a weather tightness point of view, what are the most commonly seen problems? Replacing packing rubber without fixing the bearing pads. If your packing rubber is damaged, if it has a deep imprint, most probably you will have a problem with the bearing pads. So check them first, repair them, and then replace the bearing pad. Installing back strips, improper repairs, mixing old and new rubber, I mean, is not good practice. Using small pieces to fill up some gaps, improper preparation and maintenance of the channels, and ordering rubber that deviates from the original specs just because it is cheaper. Remember what I said before, cheap packing rubber may not be good, and a good packing rubber may not be cheap. Mechanically speaking, listen in the first place to the sound that is being made during operation. Abnormal sounds, really sound that make your ears or that hurt your ears, I mean, that is definitely not good. Grease moving parts, but we see that there is no greasing plan. There is no greasing carried out, and when it is carried out, most of the time, it's not done in a proper way. And in many cases, people try to solve mechanical issues by onboard repairs. And as you will understand, hatch covers are fine pieces of engineering with small tolerances. Having this done on board by the crew is really a challenge. Hydraulically, we do see a lot that filters of the power packs are being cleaned instead of changed, that people are closing covers without a pump, that that pipes are being changed without being properly flushed. The valve position is not respected according to the manual when the ship is at sea, and where small leaks are ignored. So I hope that you found this presentation, as David said, took a little bit longer than an hour, but I hope that I was able to give you a good overview of the important things that are related to hatch cover inspections, hatch cover maintenance, and I do hope that it will help you during your further activities and your day-to-day work. I would close my presentation here, and I would give things back now to David, and we will still be available for some time for additional questions. If you would have questions that are not being tackled, don't hesitate, send them by email to our email address, and for sure you will get an answer, or why not, we can get a small chat over online. Okay, thank you very much for your attention, and David, it's back to you now.
Wow, Walter, that was a tour de force. Thank you very much. Before I launch into questions, because I think you need a little bit of a break, I'm just going to do a small advert that I was going to do at the end, but you have a sip of water and get your voice back. Right, so, okay, Walter's book is available for sale. The normal price is £115. It can be purchased over our website, but, and here I go into my telesales, but don't answer now. You can have it for 40% discount if you send a message to that email address and tell them that you saw the webinar. But don't answer now. Wait. Look at that. How corny. We're launching a brand new book on, or a brand new edition of a guide to bulk carrier operations, and that's being launched next week. It's being launched with a webinar next Thursday, so we'll be advertising that on Monday. You can sign up for that. And although that book regularly sells for £65, because you've watched this webinar, if you write to that address, you will receive 40% discount on that brand new book when it launches next week. Yeah, so those are available. I hope you enjoy them and the webinar. So Walter, as you can imagine, we're inundated with questions. So we'll plug away in no particular order. Alroy asks, what is your opinion of the use of ram neck tape on hatch packings?
The use of ram neck is actually well-known. It's well known. I mean, people use it because they find problems with hatch covers and so on, but it is not recommended. Why not? As we already said in the webinar, hatch covers which are well maintained will not leak, and therefore they do not need any extra sealant. On the other hand, some people say, yes, we put ram neck as an extra precaution, but that has actually a downside, because if you put it as an extra precaution and you still suffer wetting damage, opposing parties may actually say, well, we can see that you put ram neck on your hatch covers, you knew that they were leaking, and then actually it will be up to the ship to prove that everything of the hatch covers is in good condition, that the hatch covers are well maintained, not leaking, and only then it can be considered as an extra precaution. But as you can imagine, that is not easy, and it may actually put the ship owners or the managers in an awkward position when they have to defend the claim. So, okay, so be careful with the use of ram neck, even if people would require it, and it is frequently done by charters to say, okay, captain, can you please put some ram neck on the hatch covers? Sometimes they will even pay for it and so on. But I mean, beware that you can only consider it as an extra precaution on condition that your hatch covers are in a perfect condition and that you can prove that.
Okay, thanks, Walter. Just before we continue, there are a couple questions about the books. Members normally get 30%. Now we're offering 40% for everyone. You do not get another 30% on top of that, and we will ship anywhere in the world. Right, question from Leo. Must class be involved in every type of hatch repair?
You have to consider that a hatch cover design is approved by class. From the moment you are going to do something that alters that design, then class should be involved. Class should be involved for two reasons. I mean, first of all, because they are the approval body of the design, but secondly, it may also be that class is has been delegated by the flag state to check the statutory requirements, in which case they are checking load line and safety construction on behalf of the flag state. So if that is the case, class can actually be contacted, first of all, to confirm that things can be changed and to do the necessary with the change in design. And secondly, they can liaise with the flag state to keep them involved of the type of repairs that have been carried out.
Okay, thank you. Question from Liang. Are there any staff in the hold when you do your ultrasonic test?
That is normally not required. I mean, you can position your transmitter in the hold, you can come out of the hold, and you can then basically carry out the test. There have been...
But yes? there wouldn't be any hazard to personnel?
No, there is no hazard to personnel of being in the hold when the transmitter is there. On the other hand, one of the advantages of ultrasonic testing is just actually that you can do it on your own, that there is no need to be in the hold for anyone. And I would say that the idea of having someone in the hold during a hose test is actually also not really necessary. If you want to know whether hatch covers are leaking, you will already get, during a hose test, for instance, you can see that water is leaking out of the drain channel, which would be the first indication to get an idea that water is passing through the packing rubber and the compression bar. And if later on, after the test, you would open up the hold and you see a swimming pool in the hold, then you know that not only water was leaking out of the drain, but also going over the drain channel, and that you really have a big leak. So for people who have to carry out a hose test and who are alone, I mean, putting a plastic bag on the drain valve may already help in visualizing that water passed through the drain valve during the test.
Okay, thanks, Walter. Could you, there are a couple questions about what the difference is between the hose test and the ultrasonic. I mean, obviously one's using water and one's using sonics, but when do you do which one? Or do you do them together when you do an inspection?
No, good question. Actually, I mean, with a hose test, you are going to check if you, how would I say, if you have a contact between the rubber packing and the compression bar. So if you have a contact, a physical contact between the rubber and the compression bar, water will not pass. And that would be a point where if you make a hose test, you don't see water in the drain channel or in the hole. When you make an ultrasonic test, the ultrasonic test has the ability to check the compression that is on the packing rubber due to just because of the physics of ultrasound. That's a little bit too long to explain here, but we can check the compression. So from the moment that we are going to make a test with ultrasound and we hear something, we are basically not finding a leak, or not necessarily finding a leak that would allow water to pass, but we are already finding an area where we have lack of compression. And as we know, lack of compression is a problem, because if we don't have sufficient compression, the packing rubber will open up prematurely in heavy weather and we get wetting damage. So that is actually what is important to know, is that when you check with ultrasound, you look for compression or lack of compression. If you find lack of compression, that can still be that if you make a hose test, water will not pass through that specific spot, but you do know, thanks to the ultrasonic test, that it is a dangerous spot that you have found, and that should be found out why it is actually giving you or returning measurements that are above the 10% fail pass criteria.
Thanks, Walter. You touched on this in your presentation, but maybe I missed it. Is it possible for ships to carry their own ultrasonic testing?
It is absolutely possible to have ultrasonic testing gear on board. There are a number of shipping companies who have it, especially in the dry cargo market then. And I think it is good practice. And if people would develop, let's say, the habit of having it on board, making a test at regular intervals, using the free downloadable software and reporting forms that you have and keeping everything in a hatch cover file, I mean, it would really constitute perfect evidence to prove that you are maintaining your hatch covers and taking care of them in a proper way. And it would significantly facilitate dealing with claimants in case a claim would be filed for wetting damage. The second part of that question is, would it be difficult to make or to train crew to carry out the test? Basically, ultrasound is quite easy to use. It is not that difficult, and what we have seen over the years is that even if it is always preferred for people to be properly trained during training courses that are organized by SDT and by ourselves, I mean, it is always good to be trained. But in many cases, we see that superintendents are coming to a training and then they try to explain it to the chief mates and so on. And I can say that with those people who follow that path, it has resulted in quite good results and quite good, let's say, reliable results. And it allows the ship to build up a history of hatch cover tests, which can be used in their favor in case of a problem.
Right. And is it all the transmitter? Is it always portable, or do some ships have fixed transmitters in the holds?
It is portable equipment. It is in the old days it was quite bulky and heavy, but nowadays, thanks to modern technology, I would say it is it's lightweight. It is powered with normal batteries and so on. So it is very easy to use. And in a number of cases, the transmitters, they have a magnet, so you can even stick it to the bulkhead or to a container or a steel coil or anything like that.
Okay, thank you. Captain Kingsley asks, what's your opinion of loading heavy cargo on top of hatch covers? Could this be considered as normal operation or non-conformity?
Well, first of all, of course, the hatch covers must be fit to receive a certain deck load. That is the first thing. And secondly, is it normal to load cargo on the hatch covers? If they are designed for it, you can do it, but you should check that you do not overload the hatch covers, because then you get again into the danger zone. You should not be too much afraid about damage to the packing rubber, because that is still what people think. The hatch covers are resting on the rubber packing, so if we put something on top, then we will get a situation that the packing rubber will become over compressed. No, after this webinar, people should know that the panels are resting on bearing pads. They are taking up the load. So you should not really be aware of damage to the packing rubber because of that. But of course, I mean, the overall strength and integrity of the hatch cover should not be exceeded.
Okay, thank you. Question from Yurley. Based on your experience, what is the best hatch cover construction? So obviously you mentioned that different types of ships have different hatch covers, probably to do with their cargo handling. But is there a preferred type of hatch cover?
No, I have shown in the beginning of my presentation 8 different types, and for sure there are some more. But the most frequently seen type of hatch covers that we have now are the folding type hatch covers, which we see on the handy-size bulk carriers. We have the side rolling hatch covers, which we see on the Panamax and the Cape-size bulk carriers. And we see pontoons, pontoon type hatch covers, more and more on container vessels. So these are 3 commonly used hatch cover types. And then, I mean, on smaller tonnage like mini bulkers and so on, we see also a pontoon design, but there we have a pontoon design whereby the pontoons are generally operated with a small gantry crane or with a jacking system on the ship itself. So, but I mean, if we would go back to the presentation and we would look to design issues, you would already see that there are a lot of things to be considered for building hatch covers or making hatch covers. So it is up to the ship owner when he orders the ship to consider what will be the trade, what will be the requirements, and to do that in a thorough way and make a good exercise of it, to know that those hatch covers will actually satisfy the needs of the trade, the expectations of the ship owner for several years ahead.
Okay, thanks, Walter. I've got a question here from Gregory. Are there any restrictions as to maximum ship's trim for proper hatch positioning for the coamings and correct ultrasonic testing?
Perfect question. I mean, hatch covers, if you look to the manual, most manufacturers will actually stipulate or will clarify in the manual to what extent of trim or list hatch covers can be operated. That has not so much to do with the tightness, but it has to do with safe operation conditions. And therefore, what I would recommend is that we should try, or that the chief mate, for instance, should try to consider during the loading operations what will be the different stages of trim that the vessel will be going through until she's finally loaded. Because operating hatch covers out of that range can result in problems, in accidents. It may prevent actually panels to be closed properly. It can cause derailing of hatch covers during opening and closing. So definitely trim, list, and coaming deflection are things that have to be considered even when you are making up your discharge or loading plan. It's always good to give it a thought.
Okay, thanks, Walter. We are getting very tight on time, so I think I'll just take one more question. And it's actually a combination of questions. Quite a few people asked this. Could you just stipulate a little bit more on the difference between weather tightness and water tightness?
Well, as we said in the beginning, weather tightness is actually or means that water should not get into the ship, and that water should not get into the ship under any conditions. So the water that we are talking about under weather tightness means water that is coming from the outside. So we can refer to it as water that is acting on the hatch covers, but from one direction only, from the outside. Okay? And of course, depending whether we have big waves breaking apart on the hatch covers, we are really creating weather load on the hatch covers. If it is just gentle rain, okay, I mean, that is a totally different load that is acting on the hatch covers. But whether it is snow, whether it is rain or ice or sprays, green seas breaking or acting on the hatch covers, none of the water by these phenomena should actually get into the hold. Okay? When we talk about water tightness, we are going to say, well, water should not pass from bottom or from down to up through a sealing system or from outside to inside. And that is why with water tightness, we are talking about a certain, let's say, there it is not only the tightness as such that is important, but it's also the fact that water should not pass under a certain head of pressure through a sealing system in either ways. And I think that ro-ro vessels are a good example. If you have a ro-ro deck, I mean, water that would accumulate on top of that deck should not go down. But if you have water or a lower compartment filling up with water due to grounding or due to collision or whatever, I mean, that water should not pass and pass on to the next compartment above it. And that is water tightness. So with water tightness, there is that certain degree of pressure that plays a role in both directions.
Okay, thanks, Walter. One more question. Again, this is a culmination of different questions. People are asking about the effective heat. So very hot climates or very cold climates. What's the effective heat on packing?
Packing rubbers are normally designed to withstand a specific range of temperatures. Of course, I mean, if you get situations where it is very cold, your packing rubber may suffer a little bit from cold, making it, let's say, less flexible, a little bit more brittle, and so on. And it is always good to confer with the manufacturers of the seal to see what the temperature ranges are for a specific seal. I know that under, let's say, the influence of Arctic trading and so on, manufacturers of packing rubbers are looking into this and also trying to find, let's say, a suitable packing rubber that allows trouble-free trading even under extreme cold temperatures.
Okay, thank you. Right, Walter, we've been at it for an hour and a half, so I think we'll give you a break. But thank you ever so much. There's so much praise coming in over the system, which I'll share with you afterwards, but it's been really useful. I might remind people that probably by tomorrow, this presentation will be on our YouTube channel, and there's so much information in it. You may have to watch it a few times to pick up everything.
Yeah, if I may just add something, yeah. David, is that on the presentation you will find the email addresses to contact us. You will find also let's say the links for downloading free software, and depending on the amount of questions that will come in, I can also tell that with us at the office we have a team of people who are able to answer questions, so that we can actually or hopefully respond to the questions of people in a reasonable delay of time.
Okay, thanks. And just if you missed it, Walter's email address is there. It's walter@imcs.be.
Yeah, so, and whether that is about hatch covers or ultrasound, I mean, never mind. We will get it. We will deal with it in the right way.
Okay, thanks, Walter. Again, if you want these books, you can download a handout that has some more information, and the new bulk carrier operations book, there's a brochure for it on the handouts as well, so you can download that in the next couple minutes. I will just remind everybody that we are a membership organization. That's how we survive. So if you would like to join us on this voyage of sharing information and learning from each other, please become a member of the Nautical Institute, and it would be great to have your support. So on that, Walter, I will thank you very much. Great presentation, and I'll invite you to log off, and then I will close the meeting for everybody.
Okay, thanks again for giving the platform, David. Much appreciated, and it was a pleasure.
It's our pleasure. Okay, Walter, bye now.
Thank you. Bye-bye.